Okay, here we go with a fairly common question, all about refractive indices and wavelengths. Have a look, and then we'll get moving. Okay, so we've got a wave moving from medium 1 to medium 2, and we're being asked to compare the refractive indices N1, N2, and then the wavelengths lambda 1 and lambda 2. I think it's always a good idea to draw the normal, so let's do that. Just to sort of confirm in your mind what's going on here. We have got a ray of light which is bending towards the normal. Okay, now hopefully you're aware that when a wave bends towards the normal, this is like what you might see when air to glass, for example, that means the light is slowing down. Okay, so what this means if we're comparing speeds is that speed 1 is greater than speed 2. Now notice here on the selection here, we don't have anything about speed, but we do have something about a refractive index. You should know that the higher the refractive index, the lower the speed. So this means that the refractive indices behave in the opposite way. It means that my refractive index in 2 is going to be greater than that in 1. And that really is to do with the fact that the refractive index tells us by how much the light will slow down. So we can get rid of a couple of our answers. This is the sort of combination table element of it. These two are going because this is saying that we've got the opposite relationship. Again, as with all these questions, if you're in an exam, you could have a guess at this stage. You've done a bit of ruling out, but let's see what the actual answer is. For this, we're going to use our old equation V equal to F lambda. And we remember that the frequency is always constant. Okay, so whenever a wave travels from A to B, from 1 to 2 in this case, the frequencies are always the same. What does that mean? Well, we can use our equation V equal to F lambda. If the speed is going down, then that also means the wavelength must go down. And as a result, that means that my wavelength in medium 2 is going to be less than my wavelength in medium 1. Or in other words, my wavelength in medium 1 is going to be greater than that in medium 2, which then leads us to the answer, which is C. As I've said, this is a really common question, combining those definitions of refractive index and of our using our wave equation there. So there's a lot going on here. However, I hope you can see that there are repeated structures in here. You often get a couple of these choices: refractive index, speeds, wavelengths, even frequencies, and you're asked to kind of think about the comparison of the two. Hope that helps.